Alright, the triangle angle bisector theorem. Kind of a tongue twister there. If an angle of a triangle is bisected, then the bisector divides the opposite side of the triangle into segments that are proportional to the other two sides. So what does that mean? So what that means is here I have an image of it, and I'll kind of move things around a little bit so you can see it better. There we go. And so we've got AD here that cuts angle A. It bisects angle A, cuts it into two equal sides. Here you can, or two equal angles. Here you can see it at 41.6 approximately on each angle. And then you have BA there is 7.3 centimeters, inches, whatever your units are. BD 4.94, DC 3.57, and CA is 5.28. What's nice is these are proportional. So BA over BD is the same as CA over DC. And you can see that here. So I've got each of these. And the bottom is when you actually divide those two numbers. So right now it's set at 1.48 if you divide 7.31 by 4.94, and it's the same as 5.28 divided by 3.57. So if we move B around, the side lengths change and dividing them change, but they're the same on both sides. They're proportional. So this is showing you kind of the scalar factor. So there you have it. And so it doesn't matter how I do this. AD still cuts the angles in exactly two pieces, and BA over BD is the same as CA over DC. So that's what it is. Now let's do a few problems of like what you would see in a textbook. And so using kind of the same image, I took one of the sides out. In this case I took out BD. We'll call it X. So we want to find that length. So see if you can set up the proportion and solve this thing. Hit pause and try it out. Alright, so to do this you go 12 over X equals 8 over 6. So if you cross multiply that, that would be 8x equals 12 times 6, and 12 times 6 is 72. So 8x equals 72. Then you divide by 8 on both sides to get x by itself, and x is 9 in this case, which you always double check these, especially if you're in a let's say an ACT test or a college entrance exam, that 9 there is proportional to the rest of the segments. And you can see it looks bigger than the 8. So there you have it. There's one example. Let's try one more. So here's another example. Give it a shot. So solving this one, 5 over, and we'll call that x, that BD that's missing. 5 over x equals 8 over 6. You cross multiply, 8x equals 30. You divide by 8, and x equals, and you could leave it an improper fraction. If you took 2 out, that'd be 15 over 4, or 3.75. And there you have it. That's the angle bisector theorem. So I hope this helps, and see you next time.